Alright, very good morning. Today we're going to do chapter 4 vectors. Right, before I start what is vectors, let me give you some idea, okay, some basic idea understanding on what's going to go on in this chapter. Let's say I draw a point here. Okay, let's say I draw a point here. Maybe the point is 3 and 4. Okay, this is the point. I denote it by A here. Okay, now if I want to find the length of the point, okay, the length of the point here, how to find the length of the point, use Pythagoras theorem. Okay, use Pythagoras theorem. Basically you can find the length. This is 3, this is 4, and if you use Pythagoras theorem, if I want to find this hypotenuse, I suppose you guys know what is hypotenuse, and if you want to find Pythagoras theorem, this is 3 square 4 square, you will end up with 5. Okay, now this is 5 here. Okay, so OA, the magnitude, okay, the length of OA is 5. Now that is, let's say that is your some length of the line. Okay, this length can be anything. Okay, we can denote this length as a any unit. Later I'll go through that. Now if I put another point here, which is B here, that this can be -3, this can be -4, and if I want to draw another line here, okay, that's going to be OA. And if you find by using Pythagoras theorem, if you want to find this, again you're going to get 5. So the length of the line is 5. Okay, now what is vector? Vector is any measurement, okay, any measurement, we call that as any magnitude, any measurement with direction. Okay, so let's say OA, now I put this direction. Okay, that is now OA is now known as a vector. Now how to write this? Normally we write it, put here the arrow goes from O to A. It has a direction now. Okay, what it has a direction and it has a magnitude now. Magnitude is 5. The length, we call this as magnitude. Okay, any measurement, okay, any unit, any measurement with direction and magnitude is known as vector. Okay, any measurement like OA, no, I don't put this one, no direction, just 5%. This is known as scalar. A unit with magnitude only, okay, a magnitude only, it is known as scalar. A unit with magnitude and direction is known as vector. That is a difference. Now if you ask me, just now OA was 5 and OB was 5. Therefore, by scalar, OA is equal to OB. Okay, both are 5 and 5. Now for vector, OA is 5. Now OB is, you can see the direction now, OB, the direction goes down. The directions are not same. OA is going upwards, OB going downwards. So if I want to write OA, vector OA like this and vector OB like this, both are 5, but then since the direction, one goes up, one goes down, therefore vector OA is not equal to vector OB, just because of the direction. So in vector, direction plays a major role. You have to understand that. Okay, that is the major difference between scalar and vector. Now if you ask me what are the real life example for vector to differentiate, I can give you two real life situations. One is distance. Scalar can be distance. Distance means you go this way 5, you go this way 5. Okay, let's say your home is here, your shop is here, and then a mall is here. The distance from a shop is 5, the distance from the mall is 5, both distance are same. Okay, both the distance are same. But when it comes to vector, we call this now, since vector have a displacement, vector has a direction, we call that distance now as a displacement. Displacement, both have same ideology. Okay. For S is here, M is here. If you want to go for shop, you are going this direction. If you are going to go mall, you are going this direction. Direction are same, different now, but the distance are same. Magnitude is same. Distance is same. Direction is different. Therefore, therefore the vector HS is not equal to vector HM. This is how you have to think. Okay. Another example I can give you is speed and velocity. Both have same unit. This is also m meter, distance over time. This is also distance over time. Speed, as I told you, if your house is here, shop is here, if you take a car or motorbike, let's say the distance, okay, the speed you are going here may be I don't know, 70 km per hour. A mall also same, maybe 70. The speed is same. Speed is same. Speed don't have direction. But when it comes to velocity, is different. When it comes to velocity, it is different. One going left hand side, one going one is right hand side, one is left hand side. Okay, you have to understand. Vector quantity have vector quantity. Normally going right, we put positive for right direction, and or upward, vertical, upward. I just put upward here, upward direction. We put negative for left and downwards. So whenever a direction goes to this way and this way, it is positive. Whenever direction goes to this way, left to right, it is negative. So vectors, vector quantity, we call it vector quantity, have positive and negative. Scalar, just now scalar, distance, speed, they don't have this plus minus thing. Okay, this is one difference between scalar, vector. Okay, what is scalar in real life? Maybe distance. What is the corresponding vector unit, vector quantity? That would be displacement. What is the another example of scalar quantity is speed. What is the corresponding vector quantity? That is velocity. Just to give you some idea what is vector and scalar, how the vector works. Vector, normally you have to think it has direction. If it has normally if it has right, it goes right and upwards is positive. If it goes left and downwards is negative. If it goes like in a diagonal movement, we have to see certain character, whether it's positive or negative. Okay, but basically this is the whole picture of for this syllabus, for whatever I'm going to go through. If you can understand this, that would be nice. Now let us go through the slide now. As I told you just now, scalars and vectors I have introduced the thing. If you see, you can read yourself. Scalar is simply a real number, just a number or quantity that has magnitude. Okay, just we can quantify, we can measure the quantity only. For example, length, temperature, blood pressure, mass, volume, density, all these are vector. Okay, I mean all these are scalars. Sorry, all these are scalar. Now what is vector? Vector has magnitude and direction. Okay, so for example, weight, where does you have a weight, isn't it? You have a weight. Some of you have 80, some of you have 90, some of you have 50, 60. That is a magnitude. That is magnitude. Where your weight, where is the direction of your weight? Your weight is going downwards. Okay, gravity, towards the gravity. Because of the gravity, you go weight going downwards. That's why we can walk. If you don't have, if your weight goes upward, we can fly, something like that. Okay. Now, velocity. As I told you just now, velocity is also a vector quantity. We can compute the magnitude. Okay, let's say the velocity go by 50 meter per hour, something like this, or per second. This is the magnitude. You kick the ball. Where is the direction? The direction goes this way. Okay, the same goes frictional. If you go, if any of you took physics or have learned kinematics or mechanical part, you have force. Okay, the force, when you push something, you feel difficult, isn't it? When you push some let's say a cupboard. Okay, there's something resistance, resisting you to go smoothly, and there's a force. We call that as frictional force. Anyway, this is all ideology. You don't need to go through it technically. As long as you understand what is vector, it has magnitude and direction. Don't worry about a force or work, anything. We are not going to go into physics and mechanical part. Alright. How to represent a vector? Okay, just now I draw OA. So I represent this vector. The direction goes from O to A. So this is one direction. If I put A, B here, then I write like this, A to B, the direction A to B. Or simply I can denote it by a letter A. Another notation is A tilde. Okay, normally when we use bold, this is bold. When they print, they print a vector A, they put it bold. Okay, but when we write, we cannot write bold, isn't it? We're just going to write like this. So to differentiate a letter with a vector notation, we put a tilde here. Okay, so both all these are notation for vector. Okay, normally all the vectors we will denote it by a line with a direction. Okay, so all the vectors just now I draw. Just now remember I draw here 0 and A. The basic numbers for vector is the point coordinate of A. So what is the coordinate of A just now? That was 3 here, 4 here. The coordinate is 3, 4. So when you want to write vector, okay, OA, vector OA, we can write it as the x coordinate up, y coordinate is down like this. We call this as column vector. Okay. Another notation is simply like the coordinate is just when you write like this. If we say point, then it's just a coordinate. If we say vector, then this notation takes the ideology of vector. Okay, simple. For this syllabus here, this chapter here, for simplification, I think we are going to use this notation. Another notation for vector is you write xi and yj. Okay, this is something another. There's another notation also like this for vector, but we will just focus on just one simple notation. For our later we're going to do some computation. For 3-dimensional is the same thing. Okay, 3-dimensional we're going to draw in 3D. Okay, if I put one, this is, let's say 1, 2 and 3 here. Basically how to draw this, we put a triangle here and put a triangle here. I mean we are not going to ask you to draw. So the point is here. If I want to if I want to draw this vector 1, 2 and 3, this is a vector in 3D here, 3D. You put a line here now from 0 to the any point, maybe A here. So that vector OA now is equal to 1, 2, 3, something like this. Okay. Now geometric representation is the same thing, like in 3D. Yeah? In 3D we will draw a rectangle like this and then we join. This is the point, we join the point, this is the vector. Okay, sketch a point, this is point, this is not a vector. Sketch the point in 3D space, you're going to sketch like this. Okay, put a 1 here, put a 2 here. Just now I draw, just now same thing. You put a first you draw here this rectangle and then draw this rectangle and then try to draw a 3D. This is just a point, you no need to join, this is just a point. If I want to draw a vector, as I told you just now, this one we can write it as, there's a 1 here, -1, 2, 1, -1, -2. Yeah, we're going to use this notation for vector. 1 just now, 1, -1, 2. The 1 is here, and -1 is this side, and 2 is here. and you draw a 3D uh, cuboid kind of thing, and then you join the diagonal. Basically, just to show you the geometrical representation of a vector in 2D and 3D. 2D means just a Cartesian coordinate like this. 3D means is like this. Okay? 3 axes. Sketch a vector again. This one for 2D is easy. You put 3 here, -2 here. You join the one I did just now in the first slide. Okay, operations on vector. Vector is actually a quite easy chapter. Okay, so you can do this in one day. It's very easy. Just algebraic computation is there. It's very easy. Don't worry. Why we put vector in our syllabus is because after this we are going to go through matrices. Matrices is just an expansion of vector. Okay. Later on we will go through that. After this we are going to matrices, whereby why we need to learn matrices. Later on, when you go to management science, you will come across another chapter there called Markov process, whereby you need to use the application of matrices. So all are interlinked. So just learn the basic. This should be suffice. No need to go in very detail. Vector is a very big topic. Okay, we no need to go through into the detailness of the vector. Just some basic operations should be suffice for you to cater yourself to the next chapters related to maths and stats. So in operations, if I look at here, you don't need to memorize all these operations. No need to memorize. Just go through this. I'm going to go through each and every operation. Almost, not each, maybe not all the operations, the most of the operations. I'm going to go through most of the operations here with an example. If I show you an example, then you understand more. All these operations you can go through by yourself, but I want to go through this with an example. Okay, go here. Okay. Just focus on this example here for you to prepare for your test or final. That is suffice. Okay, that is sufficient. Just prepare, focus on this, try to learn this. Now here they have given you a vector 1 1 2. This is vector. When I put a here, don't think there's a point. It's a vector. We are learning vector. This is vector now. This is the notation we are using now. A plus B. So what you do? A plus B. You plus this one plus this. Okay. Go by corresponding points here. Okay. Yes, this one plus this one. 3 and 1 plus 0 1 and 2 plus 3 5. Okay, like this. Minus also the same thing. One minus 2 is -1. 1 minus 0 is 1. 2 minus 3 is -1. Three A 2 B multiply 3 inside here, 2 inside here, and then do the normal thing, plus. That's it. And for 5 thing also, same thing you can do. this is the answer you're going to get. So plus minus basically is quite easy. Now magnitude of A, just now our A is what? 1, 1, 2. Okay, so any vector, let's say A, B, C here, this is, let's say this is a vector. The magnitude is, the formula for magnitude is A square, B square plus C square and square root. It's like almost like a Pythagoras theorem, or finding the length formula. So you will get cert 6. You can leave it the answer like this. Magnitude of B is the same thing, you can see here. Okay, I know you to do, you know these things. Okay, now that is regarding the sum operation we have done. Now we are going for distance formula. Distance formula is almost the same with the point formula. Okay, just look at this. You have two vectors here. Find the distance between A and B. For example, this vector here, for example, this vector is, let's say this vector is okay, this vector going A here, this vector going B here. Okay, this is the point. So if they're asking you what is the distance between A and B, we're going to find this distance from here to here. Okay, this is the 0 here. Origin, this is origin. So let's say A means I put a A here. Okay, let's say I denote this like OA, I did like this. And OB, maybe I can write it like this. So A is here and B is here. So basically you are finding the distance from A and find this distance between A and B. It can be in this direction or in this direction, both directions okay. So how to find the distance? Use the formula here, this formula. Okay. The distance like this, A minus B or B minus A is 1 minus 2 here, 1 minus 2, same thing, 1 minus and 2 minus 3. If you do this, you will get cert 3. Quite easy, this is also easy. Okay, you just follow the thing. Now unit vector, there's a one ideology, one notion of known as a unit vector, whereby once you find the unit vector, the vector has magnitude of 1. Okay, so the same direction. Okay, you want to find the unit vector is quite easy. Okay, you just follow this one. Find the unit vector of A and B. According to the formula, you need to find the magnitude first. Just now we found the magnitude already. Magnitude of A is, remember just now we found same vector 1, 1, 2, isn't it? So cert 6 is the magnitude of the same thing. Magnitude of B is so 13. So how to write the unit vector of A over my A is just now 1, 1, 2 over, hold on, So this one you can write it like this, you can leave it like this, or you can bring inside. Okay, 1 over Z6, 1 over Z6, and 2 over Z6. Same thing goes for B. Okay, you can do the same thing for B. So the answer I have given here. Okay, so this is unit vector. If you find the length, okay, you find the length of this, the length is 1. You can see. If you want to find the unit vector of A, why is so special? Because the length here, of course, it has another application. Unit vector have many applications, but we don't want to go through there because it's not covered under the syllabus. It's something to do with the length and finding the perpendicular length, something like that for vector. But it is deviating from your syllabus. We are not doing that in the syllabus. But one thing I can tell you, once you find unit vector, if you want to find the length, how to find the length? Remember, length of any vector, not length between two vectors, length of a single vector. Like this, you should get 1. Okay, all unit vectors, no matter what vector is that, if you find the unit vector, the length is always 1. That is the basic property of unit vector. Alright. Dot product. There's a 2 more ideas or 2 more notion to go. Then after that we will go to the exercises. The dot product between two vectors, okay, dot product is denoted by this. See, this is dot product. Okay, this is dot product. Okay, this is the only thing with dot product, and this is a formula actually. When I say dot product, is only this one, but we use the dot product with this formula to find the angle between two vectors. Okay, one of the application of dot product is to find angle between two vectors. Now let us look at this one only, how to find this one. Okay, how to find A dot B, that was given here. Okay, how to find A dot B is given here. It's very easy. Okay, if in 3 dimension, if you have did I give any, let's say A is 1 2 3, and B is, this is A, and B is 4 5 6. A dot B, how to write it? You multiply A times 4 is 4. Okay, A times 4 is 4. 2 times 5 is 10. 3 times 6 is 18. If you plus all these things, that is your dot product. Same thing goes for this one. In like 1 2, and A is 1 2, and B is 3 4. You do the same thing. Okay, that's how you can do this one. That is dot product. But we will integrate this with another expression here. Okay, this a whole thing is a formula to find the angle. If let's say A goes here and B goes here, what is the angle? How to find the angle? We use this formula here. Okay, as in the previous one, the plus minus operation, here also we have some properties. These properties you don't need to memorize, you want to go through also, you can go through. But the most important thing is how to do how you compute dot product, how to find the angle, and that is the most important thing. Okay, you can go through this if you want. Oh, one thing I forgot to tell you. Whenever, okay, let me go through this angle first. The angle between two vectors can be determined from this one. See, just now we have A dot B and from just now we have this formula here. This formula we just rearrange, we bring this one down here. Okay, we write it like A that is equal to cos theta. We are getting the same formula, just rearrange. It's not two formula here. We rearrange, we get, when we rearrange, we get this formula here. This is to determine the angle between two vectors. For example, before I go through, for example, I didn't give example here. Example is after that, but before that, I can show you something here. Let's say A is 1, 1, 1 and B is 2, 2, 2. Okay, so this is, let's say A goes like this. This is A and B goes like this. So basically what we're going to do, we're going to find the angle in between A and B. How to find this angle? We're going to use this formula. First of all, A dot B. A dot B is, you multiply this 2, multiply again 2 and again multiply, you get 2, 6. What is the modulus of A? 1 square, 1 square, 1 square, that is 3. What is the modulus of B? 2 square, 2 square, 2 square, that's going to be 12. So all this you put inside here now to find the angle. That is 6, this is 3, this is 12, and for you to find the angle, you arc cos. I suppose you guys know how to find this one. Press shift and cos, you will get the negative one here. And if you press this, 6 divided by 3 multiply 12. Here you get 0. This is not a good example anyway. Let me change little bit. Oh, of course no, because these are parallel. Sorry, I made a mistake. Let me put this as same ideology. This one cannot, because both vectors are not intersecting. If you want to find an angle between two vectors, they must intersect. This one is not intersecting. One goes like this, another one goes like this, because all are parallel. Never mind, later on I'll go through that. But now I'm going to change this like this. I'm going to change this. is 12, A is this one can get, don't worry, 4 plus 9 you get 14. This one is okay, then okay, right? 12 here, 14 here, 14 here, 12 here. Now so the angle you get here 22.2. So the angle just now between A and B, this angle is 22.2. That is one application of dot product here. Okay. Now let us go through some example of operation, okay, in dot product. Okay, just now I show you this, all these properties, isn't it? This one you don't need to memorize. Just focus on the example like the one we did before. Okay, calculate A dot B. I teach you this already just now. So remember, dot product we use to find the angle in between two vectors. Okay, two vectors. What is the use of, one of the use of dot product is angle, finding angle between two vectors. There's another application also. Again, it is beyond your syllabus. I don't want to go through that. Okay, just remember this one is enough. One times 2 plus so you get 8. Verify whether A and B are orthogonal. Okay, this is what I want to go through the thing before. Basically, orthogonal means is like this. We find vector, just now we find the angle between angle between A and B 22.2, isn't it? So this is not perpendicular. Orthogonal means you have to understand it is perpendicular. Perpendicular means when two vectors, the angle between two vectors is 90 degree. Whenever the angle between two vectors is 90 degree, that means A dot B is equal to 0 or other way around. Okay. Whenever you get A dot B, the dot product is 0, then the angle between the two vectors is 90 degree perpendicular. That is called orthogonal. Now verify that is this orthogonal. Verify that A and B is orthogonal or not. Is it 0? Is it 0? No. You can see here, see, this one is not equal to 0, so therefore it is not orthogonal. It has some other angles, but not 90 degree. Orthogonal means 90 degree. Remember that, 90 degree, which implies A dot B is equal to 0. Okay. I have written here in the slide here, this one you can see here. Two vectors are orthogonal if and only if A dot B is 0. I have written here. Next one is angle between A and B. I told you we have gone through this. Angle between A and B, you use this formula and you can find the angle is 25.07. Okay, that is regarding some operation on. If you can do this, that is fine. This is what I want you to do. Okay. Next last ideology is cross product. Okay, cross product. I have given you some formula here to do the cross product. Okay, basically let me explain here, but I will teach you a much easier method. Okay, I'll teach you much easier method that is also can be done. So what is, whenever before we do cross product in a matrix, anyway matrix I'll go through later. Now I teach you this one. All right, cross dot product is A dot B. Cross product A, we put a multiplication symbol here. Okay, that is cross product symbol. Now how to do this? Okay, so you put I, J, K. Okay, you put like this first. This is called determinant. Okay, you put like this. This vector you write it here. This vector you write it here. Okay, try to remember this formula, and later on I'm going to teach you another method which is much easier than this. Okay, whichever is convenient for you. Now, first of all, first you write this. You don't need to memorize this. You don't need to memorize this. How I get this? You cut this one, the first one. What you have here? I write here. That is for I, isn't it? For I. For I, you write this one here. Again, you cut the, crisscross the I, whatever is left, you write here. Okay. Minus, always minus. You crisscross the J, what is left here? A1, B1, A3, B3, you write here. You crisscross the K, you this one, you write here. Okay, so plus, minus, plus, remember that. Once you understand this, now how to do this? Cross this, multiply, multiply this one, multiply, minus this diagonal, multiply. We call this as a determinant of matrix, since we never gone through matrix yet, so I don't want to use the terminology. I want you to understand the formula first. Minus, this one also same, multiply, minus, multiply. Then the other diagonal. Multiplies this diagonal minus the other diagonal. Basically, you will get a vector here. This is a vector. Cross product. Okay, cross product will give you vector. Remember, vector. This is a vector. Or in other words, we just write it like in a coordinate form like this. Vector. Dot product will give you a scalar, just a number. Okay, dot product. Where is dot product? Dot product is a scalar, just a number. Okay, just a number, like here. Where is it? Did I do here? Here you see, this is just a number 32. Okay, when you do dot product, it's just a number, it's not a vector. Like for example, this one, you see, this is dot product, you get 12. But then when you want to do cross product, okay, we're going to do now, it will give you a vector. Okay, it's a vector. What vector is that? I'll show you in a geometric manner, in a way, in a while. Now cross product also have some properties here. You can go through or ignore it. Just I want you to practice some of the exercise here, some of the properties here. So that is sufficient. Okay. here. So if I want to find A cross B, okay, this is A cross B. First I want to write IJK 1 1 2 here and 2 0 3 here. If I cross this, what I am having, I write it here. Okay, remember plus minus plus. Okay, and then I cross here, whatever is remaining there, 1 2 2 3, I write it here. If I cross this, I write it here. Now how to find what is the next operation? This one multiply, you get 3, this one multiply, you get 0, minus, you get 3 here. Okay, this one 3 minus, there's a 1 here. Okay, there's a 1 here. How to do this? Cross 3 minus 4, you get negative 1, isn't it? You get negative 1. There's a negative 1 here. Negative negative become positive. That's how you get. Okay, basically this is 3I minus j, and then this one how? The 2 here. This one 0 minus 2, you get negative 2. So negative 2k. So if you simplify this, 3I plus j minus, that's what is written here. Okay. Now I'm going to teach you another method which is much easier. Okay, second method you can use in my class. Don't worry, you will get a full mark. This is another alternative. I'm going to erase this. Another alternative is you write A here. Let me put it in a more general method. This is, let's say, a vector ABC cross a vector DEF. So what is the cross product? You don't need to go through all these things. Of course, by formula I need to teach you. There's a much easier method. You can do this. Now the formula for this one is like this. Okay, you want to find the first number here. You cross this. Okay, you cross this. Left is how much? What is the thing? BF minus CE. Okay. For you to get next number, okay, next number, you cross this, but little bit different. You put a minus here, and then AF. Let me just double check. Hold on. One one two two zero. So if I cancel this, yeah. Okay. Yeah. So AF minus CD. For you to get the last one is a normal thing, same thing. Cancel this last one. What is left? AE minus BD. You can also use this method to quickly get the solution. Later on, once you get, you can write in terms of IJK. So if I want to do this now, my vector is 1 1 2 cross 2 0 3. What is the formula? I cancel this. What is this? 3 minus 0. And then I cancel this, multiply this, I put a minus here, multiply this 3, this one become 4 minus. Last one, cancel this, 0 minus 2. So this is actually 3 negative 1 negative 2, and you can write it as 3i plus 1j. 1j, just put j there, and minus 2k. So you can use this method also to find the cross product. I prefer this method instead of you writing all these things. Also, it's up to you, your convenient, up to your convenient. Now, just now I told you that A dot B 0 means, what does it mean? This means orthogonal. Orthogonal means what? Both vector is perpendicular. Okay. Now, for cross product also there is one thing I have written here. Two vectors AB is parallel if it is 0 vector. You get a 0 vector. Okay. Let's say you multiply this, you get 0i, 0j, 0k. Basically it's a 0 vector. We just put it as a 0. Okay, 0. Then if you get this tells A and B are parallel. Parallel means A is like this, B also like this. Okay, A and B is like this, parallel. Okay, so now is note that A and B are not parallel. Is this 0? No, 0. So A and B is not parallel. That's the thing. Okay, now all these things I have given you some exercise here. Okay, you can try. Okay, you can try first. Okay, all this we have gone through. We have gone through all this. I have given the answer here. I have given the answer. Anything you do and you don't get the answer, please ask me in the class. You go through the same kind of exercise also. Is this? Oh, there's exercise 1 for. This one is for 3. When I 3 dimension means I normally write real cube 3. Okay, vectors in R3 means if you see 3 numbers, I write it. Sometime in the definition I used to use this notation. 3 real number, and for exercise 2 I give in 2. Okay, in 2D only. Alright. Another thing is the cross product. The cross product here, this cross product here is only for R3. Okay, this cross product you only will do for A, B, C, 3 number. A, B, C, 3 number vector. Okay, only cross product is only for 3 number. If you see 2 number, I mean there's a, okay, in 2D vector, we call this 2D vector. A and B, A, B, something like that. We don't do that. So in the exercise 2 just now, all the operations is same. I will ask you same except for the L part. I don't ask you because the cross product only valid for vector and 3D. I have given the answer here. You can try yourself, and that's it. That's it regarding vector chapter. Okay. In tutorial, I also ask the same thing. You can ask. You can see here. It's quite easy. I ask you to find all these operation. Okay. For all these vectors, you can try. The answer is given here. You can see. Answer is all given here. If you don't get the answer, come and see me. Okay. You have to practice this. Okay. And as I told you in problem 11 to 20, skip the cross product because this is vector in 2D. You can see two numbers only, vectors in 2D. This one is vector in 3D. Okay. So that's all. Hope you all practice this. It's quite easy chapter, vector. I just want you to know all these operations, how to get this. Just algebraic computation here. All right. If you have any problem, let me know in the class when we see in the physical class. That's all for today. I'll see you in our next class then. Take care.